It's pretty hard to ignore all the buzz around artificial intelligence lately, right?
Yeah, it's everywhere.
And what's really powering all that, under the hood is this huge need for just sheer computational power.
Absolutely. Massive amounts of it.
So today we're going to take a deep dive into something right at the heart of this AI revolution, NVIDIA's DGX systems.
Okay.
And you really have to forget your standard computer here. These are, well, they're purpose-built machines, powerhouses designed specifically for deep learning and high-performance AI stuff.
Exactly. When you think about training these incredibly complex AI models or, crunching through just oceans of data, the sheer amount of calculation involved is, well, it's staggering.
Right.
And NVIDIA saw this need pretty early on, actually. The DGX line is really their integrated solution, this powerful mix of hardware and software, all like meticulously tuned for these tough workloads.
And the scope of these DGX systems is pretty broad. We're not just talking server racks here.
No, not at all.
They go from these like surprisingly powerful units that can literally sit on your desk almost like supercharged workstations, all the way up to being the essential building blocks inside some of the world's biggest AI supercomputers.
That's right. It's quite the range.
So to really get our heads around what makes them tick, we've gathered a whole load of resources.
We've looked at, foundational stuff like deep GPU acceleration, some good comparisons between DGX and the HGX system.
Right, those acronyms.
Yeah, exactly. Plus introductions, NVIDIA's own explanations of AI supercomputing, their kind of broader NVIDIA for AI view, and even the really detailed tech specs for the DGX A100.
Got it. So our mission for this deep dive is pretty clear. We want to figure out exactly what DGX systems are, how they've changed over time, model by model, really nail down the differences between DGX, HGX, and MGX, because those keep popping up.
They do.
And ultimately just grasp what all this hardware means for the folks, the people and companies actually building the future of AI.
Sounds like a plan.
Okay, let's really dig in then. At its most basic level, what is a DGX system?
Okay, so at its heart, a DGX system is basically a carefully designed series of servers and workstations from NVIDIA.
Right.
Made specifically for deep learning and what's called GPGPU computing. That's general purpose computing on GPUs. Using those graphics processors for more than just graphics. They usually come in rack mount boxes, and they feature these high performance by 86 server CPUs right there on the main system board.
But the real workhorse, the bit doing the heavy lifting for AI, that's the GPUs, isn't it?
Oh, absolutely. That's the core. A defining feature of any DGX is its bundle of multiple high-end NVIDIA Tesla GPU modules.
Okay.
Usually you're looking at maybe 4 to 8 of these really powerful processors per system, though, some bigger models pack in even more. And they sit on their own dedicated board.
And how they all connect and talk to each other, that must be absolutely vital for performance, I imagine.
Crucial. Yeah, absolutely critical. NVIDIA uses either their super-fast SXM socket or sometimes standard PCIe by 16 slots for those connections.
Right.
It depends on the model, offering different levels of data speed, basically. And with all that power comes a lot of heat.
I bet.
So, yeah, sophisticated cooling is non-negotiable. DGX systems have advanced thermal management, big heat sinks, powerful fans, and sometimes even liquid cooling in the more packed models.
So it's definitely not just about shoving powerful parts in a box. It sounds very integrated by design.
That's a really key point. Think of them as complete AI stacks. NVIDIA isn't just selling the hardware. They provide this whole suite of highly optimized software designed to work perfectly with the GPUs in the whole system.
Okay, got it. So we have a handle on the basic concept. Now let's look at how they've evolved. They didn't just appear fully formed. Let's go back to the start, the original DGX one.
Right, the DGX one, announced back in 2016. That really set the template. It had 8 Pascal or later voltage GPUs, packed with 128 gigs of this really fast HBM2 memory. But the really groundbreaking bit, that was the NVLink mesh connecting all those GPUs together.
NVLink, right.
Yeah, think of NVLink as like a private, super fast highway just for the GPUs inside the box. It let them share data almost instantly, which is essential for making parallel processing actually work efficiently.
Sounds like a big deal. What sort of horsepower are we talking about with that first DGX one?
Well, the first version, the Pascal one, hit about 170 teraflops of FP16 performance that's half precision.
Okay.
But when they upgraded it with the Volta GPUs, wow, that number jumped to 960 teraflops.
Huge jump.
Massive. It was revolutionary for the time. It meant researchers could suddenly train complex models way, way faster than before, outside of, huge government supercomputing labs.
And besides the GPUs, what else was inside that DGX-1 box?
Let's see. It had two Intel Xeon E5 CPUs, 512 gigs of standard DDR4 RAM. Networking was dual 10 gig Ethernet, and for storage, four 1.92 terabyte SSDs, all packed into a 3U rack mount case, pulling about 3,200 watts.
And the price tag for that kind of power back then?
The Pascal one launched at $129,000. The later Volta version went up a bit to $149,000.
Wow.
And NVIDIA, interestingly, even sold upgrade kits. So if you bought the Pascal one, you could swap in the Volta GPUs later.
That's pretty neat. Okay, so from the powerful data center box to something for your actual desk, that brings us to the DGX station, right?
Exactly. The DGX station, the first one used Volta GPUs too. That was NVIDIA's first real push to bring that kind of high-performance computing power right to your desk side.
Like a personal supercomputer?
Kinda, yeah. A turnkey AI supercomputer that didn't need, a whole data center room with special cooling and power.
So what was different about it that let it sit next to you?
Well, first off, it looked more like a tower PC. Inside, it had four Volta V100 GPUs, each with 16 gigs of HBM2 memory. That gave it about 480 TFL OPS of FP16 power.
Okay, 4 GPUs instead of 8.
Right. And it used a single Intel Xeon E5 CPU. The 2698 V4 model had 256 gigs of DDR4 RAM and the same storage and networking as the DGX-1, basically. 4 SSDs, dual 10 gig E.
But how on earth did they manage the heat and the noise? I mean, 4 V100s under load, that's going to be loud and hot for an office.
That was the clever bit. It had this really sophisticated water cooling system built in.
Ah, water cooling.
Yeah, which let it run surprisingly quiet, like under 35 decibels, even when it was working hard. That, plus not needing a data center, made it super appealing for places that didn't have that kind of infrastructure.
Okay, so after the station, they went bigger and badder again. That must be the DGX-2.
You got it.
Yeah.
The DGX-2 announced 2018, successor to the DGX-1, and yeah, it really upped the ante. Big time.
How so?
It packed in 16 Volta V100 GPUs, and these were the beefier 32 gigabyte versions, so double the memory per GPU compared to the station.
16 GPUs. Wow.
Yeah, the result was just staggering for the time. 2 petaflops of processing power, and 512 gigabytes of shared GPU memory across all of them.
2 petaflops in one box. How did they even connect all those GPUs effectively?
They use something called NVSwitch. Think of it like an incredibly smart high-speed traffic cop just for GPU data.
Okay.
It's this interconnect fabric that let all 16 GPUs talk to each other super fast without bottlenecks slowing things down. Plus, it had that massive 512 gigs of HBM2 memory, 1.5 terabytes of system RAM.
Whoa.
8 100 gigabit InfiniBand connections for networking, and over 30 terabytes of SSD storage.
Oh, grief. I can only imagine the size and the power bill for that thing.
It was substantial, a big 10U rack mount chassis, and yeah, it could pull up to 10 kilowatts.
10 kilowatts?
Yeah, price tag started at $399,000. And there was even a slightly faster version, the DGX-2H, with upgraded Xeon Platinum CPUs.
Okay, moving on. Next big shift seems to be the Ampere generation, bringing us the DGX A100. Felt like another major leap.
It really was. The A100, released in 2020, was the third-gen DGX server. Featured 8 of the new Ampere A100 accelerators.
Right.
And one really notable thing, it switched CPU vendors. It used a 64-core AMD EPYC 7742 CPU.
Ah, first non-Intel DGX. Interesting.
First one.
What about the A100 memory options? I remember there were different versions.
Correct. You could get the DGX A100 with either 320 gigs or 640 gigs of total GPU memory that used either the 40 gig or the newer 80 gig A100 GPUs.
Okay.
The top-end 640 GB one that could hit 5 petaflop PS for AI calculations, 10 pet OPS for INT8 stuff. System RAM was either 1 or 2 terabytes, and storage was super fast. PCIe Gen 4 NVMe 15 or 30 terabytes.
And the networking had to keep up with all that compute, I guess.
Oh, absolutely.
Yeah.
It had 8 Mellanox 200 gigabit per second InfiniBand ports, ConnectX-6 cards.
Wow.
But despite all that power, they actually squeezed it into a smaller box, a 6U chassis, down from the DGX-2's 10U.
More efficient price.
Started at $199,000 for the DGX A100.
And the desk side station got an Ampere update too, right?
Yep, the DGX Station A100. Same idea as before, quiet, powerful AI for the desk.
Okay.
It used a single 64-core AMD EPYC CPU, just like its big brother, and 4 A100 accelerators. You could get it with 160 gigs or 320 gigs of total GPU memory,
Performance.
around 2.5 PFLOPS of FP16. And for cooling, they use this interesting refrigerant-based system to keep it quiet.
Refrigerant, like an air conditioner?
Kind of, yeah. Very effective. Pricing was $99K to $149K, and they even started offering rental options, which was new, made it a bit more accessible.
Okay, fast forward to the Hopper architecture. The DGX H100. What were the big steps forward there?
The H100, announced 2022, fourth-gen DGX server, built around 8 of the really cutting-edge Hopper H100 accelerators.
Right.
This was another huge leap, especially for AI-specific math, up to 32 PFLOPs using the FP8 format, plus 640 gigs of super-fast HBM3 memory.
FP8, okay, and memory speed.
Also way up. 3 terabytes per second of memory bandwidth, which you absolutely need to feed those incredibly hungry Hopper GPUs with data.
And it looks like the box got a bit bigger again.
Yeah, back up to an 8U rack mount size. Needed to handle the heat, each H100 GPU alone has a 700-watt TDP.
700 watts per GPU.
Yeah. Inside, 2 powerful Xeon Platinum 8480C CPUs, 2 terabytes of system RAM, and another big networking upgrade. 400 gigabit InfiniBand. Plus, it included 2 of NVIDIA's Bluefield 3 DPUs.
DPUs, data processing units.
Exactly. They help offload networking, storage, and security tasks from the main CPUs, making the whole system more efficient. Price for the H100 started around $482,000.
And Hopper also enabled these truly enormous systems, right? Like the DGX GH200?
Oh, yeah, the GH200, announced 2023. That thing is it's an engineering marvel. It basically links together 32 Hopper superchips.
Superchips?
Yeah, each superchip has an H100 GPU and a Grace CPU tightly coupled. So the GH200 combines 32 of these, giving you 256 H100 GPUs and 32 Grace CPUs all working together.
Wow. It's
designed specifically for training absolute massive AI models. Offers a crazy 19.5 terabytes of shared memory for those huge datasets.
Incredible scale. And now, even newer, we've got Blackwell, the DGX GB200.
Right, announced just this year, 2024. The GB200 NVL72 connects 36 Grace CPUs and 72 of the new super powerful B100 GPUs.
72 GPUs.
Yeah, in a single liquid-cooled rack, it creates this unified 72 GPU NVLink domain that basically acts like one giant GPU. It boasts, get this, 13.5 terabytes of the latest HBM3E shared memory.
Just mind-boggling numbers. So clearly, for the really huge AI project, just buying 1 or 2 DGX servers isn't enough. That's where this DGX SuperPod idea fits in.
Exactly right. The SuperPod is NVIDIA's answer for truly massive scale. It's their turnkey supercomputer solution, built entirely from DGX hardware.
Okay.
It basically takes a whole bunch of DGX nodes, connects them with super high-speed networking, adds massive storage, all designed to tackle the absolute toughest machine learning jobs.
And we've seen some famous examples of these SuperPods, haven't we?
We have. Remember, Celine? That supercomputer used 280 DGX A100 nodes. For a while, it was one of the fastest machines on the planet.
Right.
The newer Hopper-based SuperPod can scale up to 32 interconnected DGX H100 nodes. That cluster delivers 1 exaflop of FP8 AI performance. 1 exaflop. And then there's EOS, which is NVIDIA's own internal AI research supercomputer. That's built from 18 H100 SuperPods, hitting something like 18 exaflop PS of FP8 power.
It's interesting, though. You mentioned storage. NVIDIA partners with other companies for that part of the SuperPod.
Yeah, that's right. NVIDIA's core strength is the processing the GPUs, the interconnects. For the massive high-performance storage needed to keep those GPUs fed, they team up with specialists like Dell, DDN, HPE, and others. Makes sense. Play to your strengths.
Okay, definitely makes sense. Right, let's try and untangle this alphabet soup. DGX versus HGX versus MGX. They sound similar, but they're different beasts.
Yeah, this causes a lot of confusion. Let's start with HGX.
Okay.
Think of HGX as like a specialized GPU module. It's a high-performance hardware unit that NVIDIA designs and then offers to server partners.
Partners, like Dell, HPE, Supermicro.
Exactly, those companies. The HGX module contains the really powerful SXM socket GPUs and that fast NVSwitch interconnect tech we talked about. It's like a standardized high-performance GPU engine.
So these server companies take the HGX module and then build their own complete servers around it, choosing their own CPUs, memory, storage.
Precisely. It gives them flexibility. They can pick the CPUs they want, the DPUs, RAM, storage, networking, everything else, to build custom servers for different needs. The HGX module is the GPU heart, the base board.
Okay.
And here's the key. That same HGX board is also what NVIDIA uses inside its own DGX servers.
Ah, okay, so HGX is the core component.
Right. It's the foundation for lots of different high-performance servers, including NVIDIA's own.
That clears things up. So DGX then is NVIDIA's own finished product, their complete server, using that HGS module inside.
Exactly right. DGX systems are NVIDIA's fully integrated, ready-to-go server solutions. They take their HGX baseboard, add their chosen components around it, fixed specs, usually, and sell it as a complete high-value AI cluster.
Gotcha.
But interestingly, while DGX gets a lot of the headlines, HGX platforms actually make up the bulk, maybe 90% of NVIDIA's server business, because so many partners build systems with them.
Okay, that makes sense. And then there's MGX. That's newer. How does MGX fit in?
MGX is the latest piece, introduced in 2023. It's a modular server platform. The key word here is even more flexibility and customization.
More than HGX.
Yeah, in a way. MGX lets customers basically design a server almost from scratch. You can pick the chassis, the CPU type and generation, the GPU type and generation. You could even potentially mix different ones plus the DPUs, everything.
So really granular control.
Exactly. And importantly, MGX supports NVIDIA's own Grace CPUs, which wasn't really an option with the standard HGX partner systems before.
So you could think of MGX as like a super customizable DGX platform blueprint.
That's a pretty good way to put it, yeah. The goal is maximum versatility. It's aimed at AI and HPC, sure, but also cloud infrastructure, edge computing, more specialized stuff.
Okay. Any trade-offs?
One key difference to be aware of. HGX relies heavily on that super-fast NVLink between the GPUs on the board. NGX often uses standard PCIe for connecting GPUs externally or across modules.
Ah, PCIe instead of NVLink for some connections.
Right? PCIe is fast, but for some really tightly coupled, super demanding parallel tasks, NVLink still has an edge in bandwidth and latency. So MGX might not be optimal for every single workload compared to a tightly integrated HGX DGX system, but it offers way more configuration freedom.
Okay, that distinction is super helpful. DGX, NVIDIA's product. HGX, the core GPU module for partners.
Yeah.
MGX, the newer, highly modular, customizable platform. Got it.
Yep, you nailed it.
Now, let's shift gears completely. DGX Spark. This sounds tiny. A real departure.
It totally is. The DGX Spark is, well, they call it a pocket-sized AI supercomputer. And it's not much of an exaggeration.
Pocket-sized.
Okay, maybe a big pocket.
Yeah.
It's about the size of a Mac Mini, weighs just over a kilogram, maybe 2.5 pounds, and sips power around 170 watts.
Wow. That's incredible.
The whole idea of having that kind of AI processing power in something so small is, yeah, pretty revolutionary.
Running big AI models locally on something that small and efficient, that's pretty amazing.
That's exactly the point. It's meant to empower individual developers, researchers, maybe even students, to work with serious AI models and data without needing constant access to expensive cloud servers.
What's inside it?
The heart is the NVIDIA GB10 Grace Blackwell superchip. That combines one of the new Blackwell GPUs with a powerful 20-core ARM-based Grace CPU.
Grace CPU plus Blackwell GPU on one chip.
Right, tightly linked with their NVLink CTC tech for super fast unified memory access. It has 128 gigs of fast LPDDR5X memory and can take up to a 4 terabyte NVMe SSD for storage.
4 terabytes in that little box, and the performance, you said it's capable.
Yeah, they're aiming for up to 1,000 TOPS trillions of operations per second for running AI models.
1,000 TOPS.
And it's got decent connectivity too. USB 4, HDMI out, 10 gig Ethernet, Wi-Fi 7, Bluetooth 5.3, and apparently you can even cluster 2 Sparks together if you need more grunt. Runs on Nvidia DGX OS, which is based on Ubuntu Linux.
Okay, but there have to be some downsides to making it that small and efficient.
Sure. I mean, the tiny size means basically zero internal expansion or upgrade options later on.
Right, what you buy is what you get.
Pretty much. And the price, while way less than a full DGX server, it's still significant for an individual looking like around $3,000 to $4,000 starting.
Okay.
And NVIDIA did mention a larger DTX station is coming later, using the even more powerful GB300 Ultra Super chip with much more memory, but the Spark is the really portable one.
Got it. So putting it all together from the tiny Spark right up to the massive SuperPods, who is the main audience for all these different DGX systems, it seems pretty specialized.
Yeah, it is. The core audience is really beta scientists, AI and machine learning developers, academic researchers doing heavy compute, and big companies, enterprises, trying to transform their businesses with AI.
So people pushing the limits.
Exactly. Folks who are training huge deep learning models, analyzing enormous data sets, running AI inference at scale, doing complex scientific simulations. The whole range, from the Spark for an individual up to the SuperPods for huge institutions or corporations, means there's theoretically a DGX solution for almost any level of computational need in AI. And NVIDIA backs this up with support from their specialist team, the DG experts, to help people actually use these powerful tools effectively.
Okay, well, we have covered a ton of ground today. Wow. From that first DGX1 concept right up to the bleeding edge Blackwell systems and that little DGX Spark.
We certainly have. You can really see the constant evolution, can't you? More power, better efficiency, different form factors, and hopefully the roles of DGX as the ready-to-go box, HGX as the partner building block, and MGX as the super flexible platform make more sense now.
Yeah, definitely clearer.
Shows NVIDIA is trying to cover all the bases in this rapidly growing AI landscape.
It really does. And, it makes you think about the bigger picture, this increasing accessibility of really powerful AI hardware, especially something like the DGX Spark. It could genuinely start to democratize AI research, couldn't it?
That's a fascinating thought.
Imagine breakthroughs coming not just from giant labs, but from, individual researchers or small teams who suddenly have this kind of compute power locally. What new ideas or applications might you, listening right now, unlock with that kind of capability in your own field? It's definitely something interesting to think about.